Hi everyone, thank you for coming today. Today I'm going to talk about Kubernetes buzzwords, everything you want to know but never dared to ask. So my name is Idan Shahar. I'm a cloud solutions architect for ISVs in Microsoft. So let me just talk a little bit about myself. So as I said, I work for Microsoft, um, and I really like to cook meat. And the interesting thing about me cooking meat is that I like to cook it in different methods. And it kind of combine my passion to technology and my passion to food. For instance, I have a smoker, and my smoker is actually an IoT device that's connected to my Wi-Fi, and using my phone, I can actually control the temperature of the meat, temperature of the smoker, and um, and and the amount of the smoke that's in the smoker. So that's kind of really cool how the technology actually affects our lives. In addition, I really like to collect shoes. So this time is actually a little bit different for me because I usually um, talk on a physical stage, and I mostly show my shoes, and I'm like, oh guys, so this is my shoes today. Make sure to look on them on the next presentation. I'm on my next session because it's gonna be another pair. So that's kind of funny, but this time I couldn't show you my shoes. Anyways, back to myself. So, um, as I said before, I'm a cloud solutions architect for ISVs. I work for a worldwide organization in Microsoft for Middle East and Africa. And the interesting thing about our organization is that we mostly do partnership. And we believe that together with the startups that we work together with them, we can drive them to a successful journey. And we believe that if a startup can succeed with us, we will be successful as well. So we help our startups to be successful on our platform, um, to do business together, to expose them to new market, and to penetrate to new business. With that, when a startup succeed, we are succeeding together. Um, I'm also active in every single media, so you can feel free to reach out to myself. I'm available in literally in every single media. So go ahead and check this out. If you want to get to my LinkedIn profile, it's very easy. aka.ms/Idan. Go ahead and check this out. If you like my session, um, please let me know, and I will be happy to share with you some more details about it. So thank you very much for DevConf to having me. I think that's a really cool situation where we're doing it live and virtually. So as I said before, today I'm going to talk about some Kubernetes buzzwords, everything you wanted to know but never dared to ask. So Kubernetes become very popular platform for cloud native applications. Um, with that, it brings a lot of innovations and a lot of new technologies coming every single day. Something is okay. Let me just wow. Okay. So every single day there are new applications that coming, um, new initiatives, new open source projects. That all of it related to Kubernetes, right? But how do we know which one we should use? How do we know if it's good for us or it's not good for us? Maybe there's something that's better for our project, for our platform, and that's kind of really tough to follow. So you're not alone. I hear that from a lot of people over like almost every single customer that I meet with or presentation that I deliver. Um, I get these questions. How do I know which project is the best for myself, for my project, platform? How do I know which initiative to choose? How do I know if I need to use a service mesh, or shouldn't I? Or maybe I should do some service discovery, or there's configuration. There's so many Kubernetes tools and innovations, and it's not easy to understand exactly what should we do and how and which project we should choose. So let's get started. So today, actually, I'm going to talk with you about a bunch of projects that I think that are really important and really interesting, and that you should know about them. You should be familiar with them. Some of them already became GA in the past 6 months. Some of them are pretty new and just announced in the past 6 months. But the idea here is actually to introduce you to platforms that you can use in the future. You can plan your projects based upon the progress of these projects, and you can use it once it's ready for production usage. So actually, I'll start with Cloud Native Application Bundle, Porter, Duffel. I'll talk about Kira. I'll talk about SMI, Service Mesh Interface. I'll talk about Azure Arc and Dapper. So far, so good? Okay, so let's talk about Azure Arc. Kubernetes is everywhere. It can be running on every single platform, every single hardware. People run Kubernetes on their cars. People run Kubernetes on different cloud providers, on their home, on IoT devices. It became really, really popular, and it became a platform for almost every single application today. But it become a little bit tough to manage different Kubernetes clusters that deployed in different environments on cloud providers or on premises. How do we manage this amount of Kubernetes cluster? It's not easy. That's kind of where Azure Arc comes to the picture. Azure Arc provides you the ability to manage every single Kubernetes cluster from one environment in Azure. And the interesting thing about that, it's not just management. It's once you connect your Kubernetes cluster to Azure via Azure Arc, your Kubernetes cluster gets a resource ID in Azure. It becomes a first-class citizen in Azure, like a Kubernetes native in Azure. And that gives you a lot of advantages. Because of the fact that it is a first-class citizen in Azure, you basically can take advantage of every single feature we have in Azure for Kubernetes, whether it's monitoring, security, policy management, rollback access control, authentication and authorization, billing. So that's really interesting. And people does a lot of Kubernetes deployments, and that's really not easy to manage everything. So I want to show you today, and this is my first demo. I'm going to show you how I'm taking an existing Kubernetes cluster that I installed in my laptop using Kind. Kind is Kubernetes in Docker. And I'm going to connect it to Azure via Azure Arc. So let's go ahead and see the demo. So okay, this is my terminal, and okay, so let's see my Kubernetes. So I have my Kubernetes cluster. Let's see, I have actually a bunch of Kubernetes clusters in my machine. As you can see, these are my Kubernetes configurations. I'm using now the Kind local DevConf. So this is a local Kubernetes cluster. And I'm going to run this command I'm going to actually connect my Kubernetes cluster to Azure. By running this command, we're actually gonna see something appears here. So I've already connected another Kubernetes cluster to Azure, so I can demonstrate how it looks like in Azure. So as you can see, this is my Kubernetes cluster. I can see the version of my clusters. I can see how many nodes I have in my cluster that's installed in my machine, on my laptop, actually. I can also apply some policies, and I can actually define policies through Azure inside my Kubernetes cluster that installed in my laptop machine. I can also see some logs and apply some monitoring and take advantage of Azure Active Directory to use rollback access control. It takes a little bit of time, but after a few minutes, we will see a new Kubernetes clusters appear here. Now, let me just look for Kubernetes in my Azure portal. And when I look for Kubernetes service, I can see that I have 4 Kubernetes clusters in my service account, in my subscription, but actually I have 5. The 5th one is an Azure Arc Kubernetes cluster. As I told you before, it's installed in my laptop. Great. So I'll let it run. It takes a little bit of time. And I'll move back to my presentation. Great. So I talked about Azure Arc. Now let's talk about CNAB, Cloud Native Application Bundle. Something is wrong with the display here. Let me just share it again. Sorry for that. Okay. So Cloud Native Application Bundle. You know, everyone is talking about packaging. Everyone is doing Helm, Terraform. But when it comes down to how do we deploy our applications to production or to different environments, we find it a little bit difficult. And it's not so smooth as we wanted it to be. That's where Cloud Native Application Bundle comes to the picture. First of all, it's cloud native and cloud agnostic. It supports every single cloud environment or even virtual machines, VMware on premises. But the interesting stuff about CNAB is that actually it lets you combine the deployment from the infrastructure side all the way to the application side. So when you want to deploy or to set up a new environment, you don't have to do anything manually. So you start with deploying or provisioning the infrastructure, and then it moves to deploy your application, including the databases, migrations, scripts, everything that needs to be running in order to deploy your application to production. So if we want to understand how CNAB works and how can we use CNAB to deploy our applications to a new environment, let's talk about what are the different parts of CNAB bundle. So I'll start with talking about a bundle that is actually a standard for cloud native applications bundles. A bundle that have different entities. It has a name of the bundle version, a description of it, some keywords. We have, of course, credentials and environment variables. Credentials are necessary because cloud native application bundle is supposed to be secured. So that's why we want to use our credentials. It has an executable image. The executable image is actually an image that tells CNAB what to do. How do I install my application? I have the installer program that this is kind of a plugin that lets CNAB know what kind of technologies you're using. If you're using Azure, for instance, you're gonna have an installer program that tells Synapse that I'm going to work against Azure, against Kubernetes cluster in Azure, or virtual machines, or anything else. Of course, we have parameters, because this should be a template that parameterized that we can replicate on every single deployment for every single new new infrastructure. So today, if you want to do it with virtual machine, that's fine. As long as you wrote your application correctly, you'll be able to switch your application from different kind of environments, whether it's virtual machines or Dockers or Kubernetes cluster or cloud native or web apps or anything else. But eventually, if you want to support it, you can use different parameters in your Synapse bundle to actually tell Synapse that you're going to work with virtual machines in this deployment, but in the other one, you're going to use Kubernetes. Now, okay, great. But Synapse is a little bit complicated. So how do we use it? How do we install an existing Synapse bundle? That's why we have Dapper. Dapper is here. It's a command line tool that lets us install bundles, manage bundles, distribute them, upgrade, build new bundles. But to use Dapper, you actually need to understand how Synapse bundle works. But Synapse bundles are complex. That's kind of where porters come to the picture, because porter is a lot easier in terms of management, understanding how the things works under the hood. You don't actually need to understand how Synapse works to use porter, because porter is YAMLed. It's all about YAMLs, and that's the interesting thing about porter. You don't have to write any bash script. You don't have to do any Docker file. You don't have to you don't have to understand any of the Synapse specs. Just use it. So let me just jump ahead and show you how a porter YAML file looks like. So as you can see in the left top, we can see that there is we're going to deploy an Azure WordPress application. In the mixings are actually the plugins that I talked before about. It's actually the installer programs. So I'm going to use Azure and Helm to deploy my application. In order to work against Azure, I need to define a bunch of credentials. So it's stored in my laptop, secured in my laptop, and the bundle actually use it. I also define a bunch of parameters. For instance, we can see the MySQL user parameter that we will use it once we install the SQL machine on Azure. So here we can see that I'm going to install an Azure MySQL machine service, actually a path service. I'm going to use a bunch of parameters that I defined before. I'm going to use my SQL user and a password that is stored in my laptop, as I said before. I'm going to use ECUS as a region. I'm defining the server name as well as with parameters, the database name with parameters as well. Some of the parameters are defined in a template, and some of them aren't defined in the template, and that actually provided by CLI. Now, as you can see, we have the output section here that it basically tells us, okay, after this deployment is finished, we will have a bunch of output that we can use in the next section. So in the next section, on the right side, we can see that I'm going to deploy my WordPress on Kubernetes cluster using Hill. Now, what's interesting here, it actually depends on the MySQL deployment. So once my database has successfully deployed, the Helm part will start, and that's kind of abstraction that inject the parameters from the Synapse bundle into the Helm chart. So as you can see, I have the output here the MySQL host, but I actually use it here in my Helm chart. So I'm injecting my SQL host into my Helm chart so it can configure my Helm chart and my WordPress application to communicate with that MySQL machine that I just deployed in before. Great. So I just want you to know that you can use Porter to abstract every single thing you're using. You don't have to use or to develop a new CI/CD pipeline for that. You can actually take advantage of your existing infrastructure as code templates, Helm charts, or anything else, Puppet, Chef, whatever you use, and abstract it and build a bundle out of it using Porter. Great. I want to talk with you about scale, because scale is everyone is doing scale, and scale is kind of really important. How do we do scale? Today we used to do scale based upon a different type of resources, whether it's CPU or RAM, or in a good case we're using some custom metrics and application metrics, right? And when your application has its threshold, we scale up our application and we add more pods. In this case, we add more resources. But maybe there is another way to do that. Maybe there is a more efficient way to manage our cluster resources, our applications. Maybe there's another method or another approach to take applications, cloud native applications that installed in Kubernetes, and scale it differently, efficient. These days, when you look on different cloud architectures, cloud native architectures, we have a bunch of ways to communicate between different applications, right? A really popular one is Eventdriven. So Event-driven actually means that you push a message inside a queue and another consumer consume this message and handle it. So how about we being proactive and scaling up our application based upon the amount of messages we have in that queue? So that way, we won't wait for our container to reach its limit, and we'll actually be proactive and add more and more and more pods to consume this amount of messages. Okay? So when we have a lot of messages in the queue, we will already have a lot of containers waiting and looking forward to handle these messages. But when we don't have messages at all, do we even have to have containers running? And the answer is no. I'm happy to introduce Kida to you. So Kida is a Kubernetes event-driven autoscaler. And with Kida, we can actually scale from and to zero Kubernetes workloads. So let me talk a little bit about how Kida works. So Kida connects to different event sources. It has a lot of different event sources. You can see the scalers downstairs here in the link. But it basically allows you to auto-scale your application to and from zero. So in case you don't have messages at all in the queue, or you don't have any event that requires a container to handle it, you will have no containers running. And the way Kida does it under the hood, it actually acts like a server metrics. So a metric server to Kubernetes. So it talks with the HPA, the horizontal pod autoscaler, and it tells the HPA that now I want to have 10 replicas of my pod. Now I want to have one replica of my pod because I have a bunch of messages in the queue. But when we don't have messages at all, it actually tells Kubernetes to disable the deployment. Kida actually brings some CRDs, some new CRDs. We can see here an example of an existing CRD. It's called scaled object. It actually connects the deployment into a specific event, into a specific, in this case, it's Azure queues, Azure storage queues. But it actually tells Kida that this deployment that we can see here is binded to the scaled object. And when we don't have messages in that queue, disable that, that deployment. But when we do have messages, scale it up based upon amount of messages. And that's the strength of the scaled object. Here we can also see that we can set a different type of thresholds to tell Kida how do we expect our application to handle amount of messages. So in this case, the lag threshold is 5, and each of our containers will handle 5 messages. You know, it's also very easy to install Kida on Kubernetes cluster. You can use the Helm install. It also supports Helm 3. And you can also install Kida on your Kubernetes cluster with Azure Functions. Now, this concept is mainly made for event-driven application, as I said before. But you know, there's a really popular and common scenario where we're actually developing serverless applications. It's kind of event-driven by nature, right? So I want to show you a really interesting use case. When we're using Kida together with Azure Container Instances, where I explain in a moment what Azure Container Instances is, together with virtual kubelet. So Azure Container Instances, it's the ability to tell, to drop a container to the cloud and just run one container without any effort, without the need to manage it. It's kind of a serverless container. Now, together with virtual kubelet, virtual kubelet is a project that connects ACI instances into Azure Kubernetes cluster, or any other Kubernetes cluster that's deployed whenever you want, wherever you want. So together with ACI and virtual kubelet, we can build serverless Kubernetes clusters that are not binded into specific amount of nodes. And when we have pods running on our clusters, they will actually can be infinitely scaled, because we're not binded into not physical machines, but virtual machines. So that's why when our application needs to scale up, it actually can scale up without any limit using ACI. Because you know, when the resources are ended in your virtual machines, what we're going to do with Kubernetes is actually to auto scale or to scale out the virtual machines and add another virtual machine as a Kubernetes node. But in this case, when we're using ACI, we don't actually need it. So we covered from the infrastructure side, we have a completely Kubernetes, serverless Kubernetes cluster. And together with Azure Functions, that we can take advantage of as serverless framework for cloud native applications, we can actually run Azure Functions on top of Kubernetes cluster using Kida and build a completely serverless applications using Azure Functions and using Kida. We can actually take these completely serverless applications and run it on a completely serverless Kubernetes cluster. And that way we can achieve infinite scale and actually have a completely serverless application all the way from the infrastructure side to the application side. So I want to show you a really quick demo here, and then I'll switch to talk about 2 more topics, and then we're done. Great. So now I have my Kubernetes cluster. Let me just switch to the right Kubernetes cluster. This is the DevConf AKS. It's a Kubernetes cluster on Azure. It's Azure AKS. As you can see, I have two nodes. I have my my AKS agent pool node, which here it's a virtual machine scale set. It's automatically scaled up and down. But I also have the virtual node. It's the virtual kubelet that I talked about. It's actually ACIs that we will have based upon the amount of containers we will running on our cluster. What I'm going to do now is actually to look on my deployment. Let's start with pods, actually. So I have one pod that's running at the moment, which is the RabbitMQ pod. This RabbitMQ pod, I'm going to use it as my event platform. So I'm going to actually push messages into RabbitMQ as a service bus, and I'm going to have different consumers to consume these messages. These consumers will be running on, of course, it's going to use Cheetah, and it also will be running on ACI. So let me show you. As you can see, I don't have any consumer running but if I look on the deployments, I do have a deployment that is called RabbitMQ consumer. But it has no pods running at the moment. 0 pods. This is scaled to 0. Now I'm going to actually put 300 messages in the RabbitMQ, and I'm gonna see what's going on. So I'm going to deploy that job. Okay, great. So that job actually is has created. And if I look on my pods, I can see that a bunch of pods is being created now. Now, let's move to watch command so you can see it on live. And as you can see, new pods are starting to spin up really quickly. And you can see that it runs on the virtual node. It's being created. More and more pods will be added to handle this amount of messages. Let me just run that command again. And we can see that new consumers has created. So this is just 300 messages. But if we think about it, the more messages we'll have, the more pods we will have. Great. One last time. Now I have a lot more pods. Great. Let's continue. I want to talk with you about SMI, Service Mesh Interface. What's going on with the display? Okay. So, there's a lot of people talk about service mesh. Should we use service mesh or shouldn't we? But there's a bunch of service mesh implementations, whether it's Istio, Solo.io, Linkerd, Consul. But before talking about service mesh, we need to understand what is service mesh, right? And in order to understand what service mesh is, we need to understand what a reverse proxy is. So a reverse proxy is actually very simple. When I on stage, I actually use 2 volunteers to showcase what a reverse proxy is, but I cannot now. So let's say I have 2 different objects that I want to communicate with. I want to send messages to that ball and to that glass, okay? So if I want to send a message to that ball and I'm not familiar with him, I have someone in the middle. and I'm telling this guy in the middle, oh, listen, send hello message to the ball. I don't know what the address of that ball, but send it to him. You already know him. Great. So I'm telling this guy, send a message to this ball, and he will send it, and as well as send this message to this class. Now I'll take, and he will do it because he's familiar with each of the resources inside my cluster. Right. Now, when we talk about service meshes, actually think of a centralized reverse proxy that every single request is going through this service mesh or this reverse proxy. Now, having one centralized reverse proxy brings a lot of advantages. We can use it to do service discovery, load balancing, service monitoring, routing. We can control the routing. We can do some tracing. We can secure service-to-service communication. We can also define some policies. So we can say which different pods or deployments can communicate with each other and which are not able to communicate or allowed. So we can define, because every single request going through the same reverse proxy, and we can tell him, oh, listen, if you get a request from service A and he wants to communicate with service B, you can tell him, no, you're not allowed to communicate with service B. So that's kind of a general explanation of what a service mesh is. Now, when we understand what a service mesh is, I can talk with you about service mesh interface. Service mesh interface is a really nice initiative that came from Microsoft, and a lot of different really known contributors to Kubernetes that joined the effort, and now they're working together on this initiative. But it basically means one standard interface for every single service mesh implementation on Kubernetes. So if you're familiar with Ingress Controller, it's exactly the same concept. It means we're using one centralized interface. In this case, it's the service mesh interface, but we can actually implement a bunch of different service meshes without understanding exactly how to use this specific service mesh, because service mesh is complex. It's not easy to learn it. It's not easy to use it. It's not easy to maintain it in production. But sometimes different service meshes are good for different needs. And if we want to jump between different service meshes, we will need to understand each of them, the different commands lines, how to use it, what are the upsides and the downsides of each of it. So using service mesh interface, it's actually pretty easy to jump between different service mesh implementations. So the way it works is actually you talk with the service mesh interface to define routing, telemetry, policies, and it tells this SMI to implement a specific type of service mesh, whether it's Istio, Consul, Linkerd, or a lot more different service mesh implementation. It's cloud native, it's provider agnostic, and that's really interesting and really cool. It's kind of a really new initiative, and you should look after that. The last topic I'm gonna talk with you about, and we will finish with that, is Dapper. Dapper is really kind of it's a really new initiative. It's an event-driven runtime for microservices on the cloud and on the edge. But what does it mean? As developers, we find ourselves developing applications for our companies that we work for. And that's our job, right? But sometimes we found ourselves wasting time, a precious time, on developing infrastructure integrations that are not necessarily part of our company's business. And sometimes it's a waste of time. We're putting a lot of effort on something that is not it's not related directly to our core business, but we have to do it because otherwise we cannot proceed with our platform. We cannot continue to develop our platform. That's where Dappers come to the picture. Dapper is actually a runtime that helps you build microservices and integrate it with a bunch of different platforms and clouds platforms. So for instance, let me give you an example. If I want to use a storage account, okay, and I want to drop a file into a storage account, what I mostly do is actually I use the SDK or the API. I'm gonna actually wrap it. I write the wrapper so it will be easier to use it inside my company. I'll put it in my common objects library, so others developer can use it as an SDK, as an internal SDK, right? So we worked on the integration, on integrating with the SDK, and then we write some tests and unit tests, and we put a lot of effort in actually implementing a way to drop a file into a storage account. With Dapper, it's a lot easier. Dapper runs alongside your application or inside your application, and you can tell Dapper, oh precious Dapper, I want you to take this file and drop it into a storage account in Azure. These are my credentials to Azure. Let me know that you succeed. And the same as with a bunch of different storage services, not necessarily on Azure, on every single cloud. So that's why it's actually not just easier to develop it, it's also easier to be cloud agnostic because you can parameterize it, you can build it in a way that it can be running on different cloud providers and actually supports a multi-cloud environment. So with that, I actually finished, and I want you. So I hope you enjoyed my session. I'll be open now for questions. You can drop it in the chat, I guess. And Candy will move it back to myself. So I'm open for questions. We have a couple of minutes for questions. Great. So there's no questions so far. If you want to study and to learn more about Kubernetes, more about interesting stuff, you can find here in the DevConf 2020, aka.ms/DevConf 2020, or otherwise you can scan the barcode here. And that's it. So if you enjoyed my session, it was really a pleasure to speak here. Feel free to drop me a line. I'm available for you in every single media, whether it's LinkedIn, email, GitHub, Twitter. Feel free to drop me a line. I really like to help others with technology. I'm really passionate about it. So thank you very much for hosting me. It was a pleasure, and I hope you enjoyed. Thank you.